Alright, now let's see question number 7. This has been framed from the chapter Work, Energy, Power. The work done on a particle of mass m by a force, and check out the force, it has been very suitably given. We'll talk about that. When the particle is taken from A0 to 0A along circular path of radius A about origin. And the correct answer for this would be option number D, that is work done would be 0. Let's verify. The value of force, if you check out, is given as K x I cap plus y j cap by x square plus y square 3 by 2, which is equal to K r vector by r cube, where r vector is the position vector drawn from origin in the xy plane, that's xi cap plus yj cap. Now the problem is miraculously simpler. This is x, this is y, and we got to take along the circular path radius a, and we have to take it from A0, it is here, to 0A along the circular path. Quite obviously, the force is the radial force, that means it's always in the outward radius, and every displacement is perpendicular to the force, so the total work done would be 0. For the additional information, this force given is conservative in nature. Now let's go to question number 8, which has been framed from units and measurement of experimental physics, where vernier caliper has been used. The diameter of a cylinder is measured with vernier caliper with no zero error. Well, that's an advantage for us. Zero of vernier scale, but the language is quite tricky, you have to be careful, is between 5.10 and 5.15 of the main scale. So clearly it indicates the least count of main scale, or we could say main scale division, that's 0.05 centimeter. And it says 50 division of vernier scale is 2.45 centimeter. That means 1 VSD is going to be 2.45 divided by 50 centimeter. Now the 24th division of vernier scale exactly coincides with one of the main scale. Let's see the reading. After this, the least count is quite obviously 1 MSD minus 1 VSD, and then the reading. The zero of vernier scale is between 5.10 and 5.15 of the main scale, so the reading is going to be 5.10 centimeter plus the 24th division of vernier scale coincides, so that would be 24 multiplied by the least count, and when you solve this you will get option number B. So therefore this is going to have answer B. Well, now let's proceed to question number 9 and 10. Alright, now let's go to question number 9, where it says two non-reactive monoatomic ideal gases have their atomic masses in the ratio 2:3. That means M1 by M2 is 2/3. The ratio of their partial pressure, that means the partial pressure P1 by P2, that's equals to 4/3, and quite obviously the temperature is same. And we have to find the ratio of the density using ideal gas equation P equals to rho RT by M and Dalton's law of partial pressure. It is very easy to find the ratio, and that will come out to be 8:9. So this one is going to have answer D. Alright then, let's go for question number 10. This has been framed from heat transfer, and the question of conduction has been made here. Two blocks of identical dimension, this and this having same length, same cross-sectional area, can be arranged as shown, which is configuration 1, configuration 2. The temperature difference is same, means the temperature difference between these two ends and this two end, that's same. It takes 9 seconds to transport a certain heat in configuration 1. The time to transport the same heat in configuration 2, that has been said. So let's see. If I call this as A and this as B, you could see that our A resistance and our B resistance. If this resistance is R, this has to be 2R. Because length is same, area is same, so this conductivity is twice, that means the resistivity has to be halved. Now, using the principle of thermal conduction, where Q divided by T is obviously delta theta by resistance, you could say the first case is an arrangement of series and second case is an arrangement of parallel. So R1 is 3R while R2 is going to be 2R by 3. And here we are going to put, we require the same heat and the temperature difference is same. So quite obviously the time taken would be directly proportional to resistance. So T1 by T2 is R1 by R2, and then you will land up with option number A. So this is going to have answer A. Alright, now let's see question number 11 and 12.